children. So once again I am here with a new video for you all, and the topic of this video is rotation and revolution, right? And today we are going to discuss about these two movements of our planet. As we proceed with this video, I want to remind you once again to subscribe the channel. You should do it, and once you go through this video you will find it very useful for you, and don't forget to share the link of this video with your friends and classmates, okay, so that they can also get the benefit of this. So let's continue with the topic. Rotation. First of all, rotation of Earth. There are two types of movements in the case of Earth. One is rotation, the other is revolution. First of all, children, when we talk about rotation, rotation means when the Earth moves on its own axis, right, from west to east, that is called rotation. And while doing rotation, when it moves around the sun, you can see in this picture, when it moves around the sun on a fixed orbit, that is called as revolution. Now the rotation is actually, in the other way you can say, it is a spinning of Earth on its own axis from west to east, from west to east. And how much time is taken by it? Once in 24 hours. That means the time taken is almost 24 hours. Then this axis is actually an imaginary line which passes through the center of the Earth, right, and it joins the two poles. The two end points through which the axis passes are known as North Pole and South Pole. And this axis on which the Earth is actually rotating, this axis is tilted at an angle of 23.5 degrees from the vertical. That means when we take a straight vertical line, from that it is a little bit tilted. And how much it is tilted? It forms 23.5 degrees from the vertical. Now when we talk about the various characteristics of rotation, we find that this movement is actually completed by Earth in exactly, you can see here what is the exact time taken. It is 23 hours 56 minutes and 4 seconds, right? When we say 24 hours, that is just round off value. So this is the actual time taken in completing one rotation. One complete rotation takes this much time. And what is the direction of its movement? From west towards east. This is the movement of Earth. Next is, the Earth is always, tilted in the same direction. That means the axis which we were talking just now, on which the Earth rotates, that axis is always tilted in the same direction. It's not that just now it's tilted this way and the other day you will find it is tilted like this. No. Always it is tilted in the same direction. Next is, the angle at which the Earth is tilted is known as the inclination of Earth's axis. That means from the vertical, at what degree it is tilted, that angle which is formed by the axis is called as the inclination of Earth's axis, right? And the next feature of it is the speed of Earth's rotation, right? The speed of Earth's rotation is actually 1660 kilometers per hour, and it decreases, it is maximum at the equator. This is the speed actually we find over the equator. But as we go from equator towards the two poles, you will find the speed decreases. So these are the main features or characteristics of rotational movement of Earth. Now next is the effects of rotation of Earth. When we talk about the effects, under this you will find different things, Number one is occurrence of day and night, right? You all know it very well. Every day we have a particular daytime and a night time also. So this is basically caused by the rotational movement of earth. The portion of earth which faces the sun, that experiences the daytime. The portion of it which is away from sun, that experiences night. Okay, so occurrence of day and night is the first effect. Number 2 is sunrise and sunset, right? Third effect is Coriolis effect. Now what is Coriolis effect? Coriolis effect is basically experienced by any object which is moving over any surface of a rotating body like earth, right? Now what is Coriolis effect? It makes any such object, right? Object, or you can say in the case of the ocean currents or the winds which blow right over the earth's surface, or the ocean currents which flow from one direction to the other, in determining their direction, this Coriolis effect plays an important role. This Coriolis effect is basically considered as one of the important effects of rotation of earth. It is caused because of this movement, right? Next is the sun, moon and stars and other heavenly bodies. It seems that all these heavenly bodies are moving in a direction east to west. Why? Because on earth, because we know that the rotation always take place from west to east, right? And we are there on earth. So when we find the other heavenly bodies, it seems that these heavenly bodies are moving in opposite direction. Just like the example I can give here, like we are traveling by bus or by train and we try to see outside. Okay, what do we find? We find all the objects are moving in opposite directions, right? Whatever objects are there, they move in opposite direction as that of our movement. So the same thing is happening here. We are there on earth, we are not moving. Earth is moving from west to east, and we find the other heavenly bodies, it seems that they move in opposite direction. Then next is centrifugal force. Again, centrifugal force is an apparent outward force that acts on a rotating object, and it is just like from the center. It is actually, it works from the center towards outside, or you can say towards the circumference of it. Now again, I want to give you one example to make you clearer this centrifugal force. If you try to notice how the mixer grinder works, mixer grinder, how does it work? From the center, right? The machine actually works from this, the blades are there in the center, okay? And whatever things we put in the mixer grinder, these blades work in such a way that all these things, all the whatever we want to grind, that is thrown outside, okay, from the center towards outside, and all these actually strike on the wall of it, right? And this is how these get broken down into fine particles. Another example, if you are not very clear, centrifugal force you can find when, suppose you are standing outside in a ground, okay, and you have taken one thread, and at the end of one thread you have tied one small eraser or one stone, and you try to move it like this, okay, round, and what do we find in that case? That when we move it like this, right, it is moving with a great speed, and as we leave it, right, at that moment when we leave that thread, we find that that stone or that eraser or whatever object we have taken, that moves always outside, okay, outside of that circle which was being formed by it. So again, this is because of centrifugal force, right? I hope this is clear to you. Now next is rotation causes difference in time. Yes, all the world over, when we say that here it is 10 a.m., that is 10 in the morning time, 2 p.m. or 12 o'clock noon or 5 o'clock in the evening, how do we know about all this? Just all these are based on at what time we are actually facing the sun, right? any longitude which faces the sun, that experiences its local time as the noon time. And accordingly, all the longitudes have got different time, right? So all over the earth, there is a difference of 4 minutes at every longitude, which we have discussed in one of the topics earlier, which we have discussed in under the latitudes and longitudes. So again, the same thing is happening here also, right? So basically, what do we find? What is the basic reason behind all these change of time at all these places? It is just the rotation. Okay, this movement of earth causes the change in time on the entire earth. Clear? Next is the side of earth, or you can say in a better way that that part of earth or that side of earth which is facing the sun, okay, it always gets more light naturally, and along with the light it gets more heat also, more insolation. But as compared to that, the side of it which is away from the sun, always that side is under dark, and so it gets less heat. So these are the main effects of rotational movement of earth. Next is inclination of the earth's axis and its significance. What is the effect of it? So for that you should understand one thing, children. What is axis? This is clear to you, right? The axis is imaginary line which is actually passing through the center of earth. Okay, and in the case of earth it is tilted. So here we are talking about what is the effect of that tilt of the earth's axis. So the main effect we can find the tilted axis has got on earth is that the length of day and night vary because of the tilted axis. If for a moment just imagine that the axis is not tilted, it is a straight vertical line, then at all the places on earth the length of day and night would be equal. But it is not. At present we can even see by ourselves that the length of day and night keeps varying, and that is because of a tilted earth's axis. So if we talk about the effect of inclined axis on the duration of day and night, we find that all over the earth, we know it very well that the duration of day and night, what we experience, are never the same at all places, right? The duration is not equal, and the time of day at any place is determined by always the height of sun at that place, right? At what height the sun is there. That means if the sun is just overhead at that place, that is going to be the noon time at that place. And according to that, as you have studied in the earlier topics also, we have discussed the local time of that place, right? So accordingly we fix the local time. So always you will find the local time of all the places, or better to say all the longitudes, keep varying. Okay, always there is a difference of 4 minutes at every 1 degree of longitude. So that means what? The basic reason behind that is rotation. And rotation on what axis? Always the tilted axis. So tilted axis is there in the case of earth, and around it when the rotation take place, that makes the duration of day and night to vary at all the places. So this is one thing. And if for a moment just think of it, if the axis is straight vertical line, okay, it's not tilted, so what would happen in that case? In that case we are going to have everywhere on earth the same duration of day and night, number one, and number two will be the temperature at all the places would be same. Okay, so these are a few things which are caused because of the inclined axis of earth. And not only this, if the inclined axis and along with that the revolution movement of earth around the sun, these two things actually cause the seasonal changes. And seasonal changes also, in what way? There is a gradual change in the seasons, right? For that, these things are responsible. Now let's talk about the effect of inclined axis on seasons. Now you can see one thing here, children. Though it is related to the revolution movement, right? Seasons are caused because of that. But yes, one thing we can find here, the duration, again duration of day and night and the duration of seasons also. Okay, let's see. The North Pole remains inclined towards the sun for a part of the year, while the South Pole is tilted away from the sun. Because we have discussed just now that always the axis is pointing towards the same direction. Okay, in the same direction it is tilted, right? So you can see here, for a certain period of time you will find the North Pole is getting actually it is towards the sun. But when you find this at the same time the South Pole is away from sun, that means it is darker and the North Pole is lighted. So that means what? For the remaining part of the year you will find the for certain period the North Pole is tilted towards sun. Okay, for the remaining part you will find it is the South Pole is towards the sun and the North Pole is towards the darker part. So this is it. That means the situation gets totally reversed in that case, and this gives rise to changing seasons and varying lengths of day and night during different seasons. You can easily get a very clear example by yourself. You will find it. Suppose at present it's the summer time, right? Summer season is there. So during summers we find the days are longer and the nights are shorter. The same thing you will find during the winter season. Suppose it is winters. During winters you will find the days are shorter and the night time is longer. So this is actually because of the tilted axis of earth. So if the earth's axis was perpendicular, right, vertical, there would be equal days and nights at all places, and there would not be any season then. No season. The portion of earth which would face the sun, it would have always the summers. The other side of it would have always the winters. So no seasonal change. Okay. So these are all due to the rotational movement of earth. Now one more question arises here. Why we do not feel the motions of earth? Have you ever thought of it? Though the earth is moving on its axis, right, and its speed is also quite high, but we are not able to feel it. Why? For that you should understand one thing, children. The force of gravity is mainly responsible for this, which actually keeps all the things. Suppose we are there on earth's surface, it keeps all such things attached to the earth, and this keeps all objects at rest, okay, with reference to the motions of earth. So you know, using this principle only, Newton's first law of motion, which states that a body remains at rest or uniform motion unless compelled to change that state by an external force acting on it. So the reason behind it is that the force of gravity of earth is such a strong force which actually keeps everything which is there on earth, it keeps all these things attached to the surface, right? And this makes all such objects which are there on the surface at rest, okay, with reference to the motions of the earth. Clear? And this is the reason we are not able to feel any movement in this case. Any of the motions we are not able to feel at all, whether it is moving on its axis or it is moving around the sun. Okay? Now next topic we have to discuss in this is revolution of the earth. This is the other type of movement of earth, right? So along with the movement on its own axis, it keeps moving around the sun also. You can see here in this picture, and when it moves around the sun, it causes different seasons, right? And this movement of earth around the sun is called as revolution. This is revolution, when the earth moves around the sun on a fixed orbit, right? Orbit means its path. Clear? Now, what are the main features or the characteristics of this movement? The earth, number one, the earth moves around the sun in an elliptical orbit, right? And its average speed is 29.8 kilometers per second, or about 1 lakh kilometers per hour. This is the speed of earth, average speed. Okay, why it is said average speed? Because as the earth moves away from sun during its movement around it, right, its speed actually gets reduced. But when it comes closer to sun, its speed gets more increased. That's why whenever we say what is the speed of earth in its revolution movement, always we say average speed. So average speed of it is almost 1 lakh kilometers per hour. Next is, when the earth is closer to sun, gravitation pull makes the earth move faster, because sun's gravitation force is very strong, so it attracts the earth towards it, so it makes the earth to move very fast, right? But as the earth moves away from sun, you will find the speed gets reduced. Okay, so the speed of revolution is not uniform. Now, the time taken by earth to make one complete round around the sun, or to complete one revolution around the sun, is 365 days, 5 hours, 48 minutes and 45.51 seconds. Okay, this is the actual time taken by the earth in completing one revolution around the sun. And the earth's axis is always inclined to its orbital plane at an angle of 66.5 degrees. Okay, orbital plane. From vertical, it is 23.5 degrees. From orbital plane, it is 66.5 degrees. Now, what can be the effects of revolution? The effects of revolution. So, the first effect of revolution is in the form of seasonal changes. Okay, revolution always causes different seasons. That is, the changing weather conditions due to differences in the heating of earth, okay, and the duration of day and night. Then revolution is an annual cycle, right? Annual means it takes one complete year. So the seasons repeat year after year. That means, suppose this year any particular season is there, again next year it will be repeated. So it is an annual process. Okay. Next is inclination of axis and seasonal changes. This we have discussed just now in the earlier part. As the earth is tilted, right, the seasonal changes are not abrupt. This you should understand. Always there is a gradual change in the seasons. This is an important effect of the inclination of axis on the season and the seasonal changes, right? And it is basically because of the revolution movement. Now, one more effect of revolution movement is perihelion and aphelion positions. What are these now? Perihelion and aphelion. There are two such positions, right, which are actually taken when the earth is closest to sun, right, and when the earth is farthest from the sun. When it is closest to sun, it is called as perihelion. Okay, perihelion. it is closest to sun, and at that time the distance between sun and earth is 147 million kilometers, right? And it occurs on 3rd January. And when the earth is farthest from sun, that is called as aphelion, right? Aphelion, and it actually occurs on 3rd of July, and the distance between the earth and sun on this particular day is 152 million kilometers, right? There is a difference of 5 million kilometers in both the cases. Clear? So this again, perihelion and aphelion, this again occurs due to the revolution movement of earth, right? Then one more thing here we can say, that the creation of heat zones, right? You all know about the heat zones, you have studied about it, right? Now, what are the different heat zones? And how do we know that this is frigid zone, temperate zone, tropical zone or torrid zone? This is basically caused because of, again, the revolutionary movement of earth. Okay? And according to the sun rays, what type of sun rays are falling over that area, we call it as torrid zone, temperate zone or frigid zone, because the sun rays, if they fall straight, they will give more insolation, right? If they are falling oblique, they will provide less insolation. Okay? So the spherical shape of earth along with its movement around the sun causes the difference in angles at which the sun rays fall on the earth's surface, right? If it would be a flat body, the sun rays would be equal on all the places, right? At the same angle it would fall. But here, because of the round shape of, or you can say the spherical shape of the earth, okay, and you can say along with that, it's not only that, along with that you will find the movement around the sun, that is revolution movement. Both these are mainly responsible for causing the sun rays which are falling on the earth, they are falling at different angles, okay, and that makes actually the different heat zones to be created. Clear? This causes difference in the distribution of heat on the earth's surface, and as a result the world has been divided into 3 distinct heat or temperature zones. And these 3 zones you can see here between the 2 tropics, right? Tropic of Cancer in the north and Tropic of Capricorn in the south. This entire part, this entire portion of earth is called as torrid or tropical zone because it is the hottest zone. So it is called torrid, right? Why? Because the sun rays fall straight in between these 2 tropics only throughout the year. Never the straight sun rays are received beyond the 2 tropics, right? But in temperate zone you will find, in north temperate zone and in the south temperate zone, you will find the sun rays fall a little slantingly. And as we move further, beyond Arctic Circle to North Pole and Antarctic Circle to South Pole, this is the zone which is called as frigid zone, or many times it is also called as polar zone. Okay, these 2 regions are the 2 frigid zones on the earth. These are the coldest zones on earth because the sun rays fall there very obliquely, right? So ultimately the heat zones which we can find here, these are created because of this movement.